Okay, we're still in vectors. Okay, and in number 3, it says to find, see that little dot here in the middle? Okay, I know it's tricky, but it looks like times, but it actually means dot product. Okay, and dot product is definitely on your formula sheet. And what we're going to do for dot product, your formula looks like this. You take the x's and multiply them, and you add it to the y's multiplied. And the thing that's interesting about dot product is that you get an actual physical number as your answer. You don't get like an expression or a component or something like that. You actually get a physical number. And we're going to use the dot product in a few minutes in examples. There's a couple of reasons why you might use it. So let's practice getting it with A and B. Okay, so here's A and B. So the x's will be 2 times 6, and then the y's are negative 3 and 5. So let's see, this is negative 15, and the x's came up to be 12, and these guys together make negative 3. So my dot product is negative 3. Okay, so one of the reasons that you use dot product, just like moments ago, is for questions like this. Find the measure of the angle between vector A and vector B to the nearest tenth of a degree. And there is a formula for this on your formula sheet, and it looks something like this. It's inverse cosine of the dot product of A and B over the magnitudes of A and B multiplied. So this is one of the applications of the dot product, which is up there in that numerator. And actually, a lot of times we make this at times, not a dot there to make that less confusing. Okay, so the dot product here is used for the numerator of this formula, which is asking for what is the angle between these two vectors. So let me kind of get a visual here, just to kind of see if my answer comes up to be reasonable. If I go over 2, down 3, okay, so one of my vectors looks like this, and then 6, 5, I don't know, looks something like this. Okay, so what I'm going to get is the angle that connects these two vectors, and it'll default to the smallest angle. It's not going to give you this reflexive angle, it's going to give you the one in between them. So, I don't know how accurate my scale is here or anything like that, but, it looks like it's going to be something like that. And again, my scale is off. I'm not using any kind of particular perfect scaling or anything like that. So we'll see, but it should look something like this. Okay, so the first thing we're going to do is find that dot product of A and B, which we actually did in the last problem, right? We found the dot product of A and B was negative 3. Okay, so the next thing that we need to do is find both of our magnitudes. So we're going to find the magnitude of A, right? And sometimes we use the 2 bars for magnitude to make it look a lot less like absolute value. So we're going to say 2 squared and negative 3 squared. So make sure you put that in parentheses. Sorry, that's a 2. And the magnitudes of B, 6 squared and 5 squared. Okay, this is a calculator allowed question. Okay, so let me go ahead and quit out of this. All right, so I'm going to have 2 squared and negative 3 squared. Again, watch your parentheses. Right, so that should be 13. So this one's going to be root 13. And this one we're going to have 36 and 25, right? Calculator allowed, so we'll just make sure we don't make any silly mistakes. Root 61. All right, so now we are able to plug this in. Inverse cosine of negative 3 over the product of negative 13, root 13 times root 61. Now, I have to make sure my settings are good, because since my last video, I did some changes. I need to make sure that I'm in degree mode. Okay, so we're going to go ahead and, oops, I need another parenthesis here. All right, we're going to go ahead and enter this in. So second cosine, negative 3 divided by, now this is really easy to make a typo. Put your whole denominator in a parenthesis. Oop, I forgot, I need to close that 13, and then times, and then I need to write the 61, close it, and close the denominator and close the whole thing. So I'll let you kind of take a look at that calculator screen real quick. So just be careful. Make sure that your whole denominator is in a big group, okay? If you kind of leave this off, if you just kind of write -3 divided by root 13 times root 61, it's just going to divide these two and then multiply by root 61. But we want to make sure that root 61 is in the denominator. So that's why the parentheses on this one can be something that kind of can be a little bit tricky. Sometimes students in my class said, hey, you know what, I'm going to multiply those together first and then, you know, use it that way, which is also totally fine. And we end up with about 96.11, let's see, nearest tenth of a degree, so 96.1 degrees. And when I kind of look back at my picture, this, you know, again, my scale wasn't good, but it looks like it's roughly around 90 degrees, maybe a little bit more. That sounds about right. Okay, find the value of r such that the vectors a and c are parallel. Okay. Okay, let's take a look. So I like to get a picture here. Okay, 2, -3 again. Again, I'm not sure how awesome that is, but that's okay. So that's A. And C. Aha, we're missing something in C. All we know is that the y coordinate is -9. So I know that, like, if that's -3, right, then maybe not -9, I don't know, it's like somewhere down here. So I know that the vector ends, you know, has a height somewhere around the -9 level. But the thing is, if they're parallel, think about that. That means they have to be, like, running the same slopes, right? So if I know that this one lands down here at -9, really, if I'm going to be going from the origin to be parallel, you know, it's got to kind of come from that origin. It's got to have that same path, that same projection, and those two are parallel to each other. I mean, they end up kind of being the same vector, just one's a little bit longer than the other. But this is certainly one way that we can figure this out. If this one went, you know, down 3 and over 2, you know, down 3 and over 2, and down 3 and over 2, you can think of it that way and see if you can figure out the x-coordinate. And that's kind of how visually I would look at it. But another way you could look at it is, okay, well, if 2, -3, and this one is r, -9, well, if I want them to be, like, on the same path, this was times 3, so this one must be times 3. So my r must be 6, all right, over 6 and down -9. That's probably the way I would figure that one out. Now, perpendicular is another story. Remember, perpendicular means they cross at 90-degree angles. So if you think about the formula we just did a few minutes ago, that one had us finding the angle between two vectors. And one of the things that we talked about in class was that if a dot product is 0, so if I want to do B and C and I want the dot product, that's not times, that's dot product equals 0, that meant they were perpendicular. Right? Because if you do any inverse cosine of 0, you get 90 degrees. So as long as I can get, you know, a 0 in the numerator, I don't really care what the denominator is, right? That could be anything. But if I can use that formula and figure out what would make the dot product 0, that's what I need. And as you can see, this is a non-calculator, so we have to figure out what's missing from the C coordinate. What's that R coordinate that's going to make, when the dot product is put together, what's going to make that 0? So let's see. We're going to have the x times the x, so 6 times r plus 5 times -9. And again, I want to figure out what makes this 0. So let's go ahead and multiply this out. This is non-calculator. Let's see, that's minus 45. So I'll add the 45 over. And I'll divide by 6. So what's that, 6 times 6? So 7.5. Or 45 over 6. Okay, and that's what's going to make the dot product equal to 0. Okay, let me try again. Okay, how many pizza toppings? Okay, how many pizzas can be made using 3 toppings from a list of 8? So we're going to have 8 choose 3, right? 8 choose 3. Now the question is this a combination or is this a permutation? All right, which one? So what we need to think about is, does the order matter? Right? So if you think about it, if you call up your favorite pizza place and you say, I want pepperoni and extra cheese and I want mushrooms or something like that, does it really matter if they put it on in that order? Or is it okay if they do mushrooms, pepperoni, cheese? Or maybe they do cheese, mushrooms, pepperoni, or whatever. No matter what they do, that's going to end up being the same, right? It's going to end up being the same no matter what. So the one where the order doesn't matter is called a combination. Okay, so this is a calculator aloud, so I'll show you 2 ways we can do this one. Okay, one way we could do this is on your calculator, you put the 8 in first, and we're going to choose 3. I'm going to hit the math button, and I'm going to tab over to probability. And combination, as you can see, is number 3. And then I'll hit 3. So 56. So there's 56 ways you could get your pizza made. Okay, let's kind of think about what this means in the long run. Okay, our formula looks like this. For a combination, it has that extra 3 in the front, rather than the permutation, which eliminates this part. It's just the 8 minus 3, but a combination keeps the 3 in the front too. And what that does is it actually makes your number smaller because it knocks away all of these repeats, right? A permutation, all of these would end up being different pizzas. But in a combination, all of those end up being the same. So this extra 3 here in the front is going to eliminate all of those additional combinations that are just repeats. Okay, so let me simplify. Okay, and maybe I'll expand. And as you notice right here, and what we talked about in my class, is as soon as I hit the 5, I should be able to stop writing all of those, right? So I really don't need to write all of those, but I just, for the purposes of this, wanted you to see a little bit more of the expansion. The 3 comes out of 6 twice. This comes out of this 4. So we've got 4 times 2, 4 times 7 times 2, and that's 56. Right? You could also think of that as 4 times 2 is 8, and 8 times 7 is 56. So either way. Okay, and then one more, and then I'll cut this video. How many different ways are there arranged? 5 photographs on a shelf. Right? So I've got 5 photographs, and here's my beautiful shelf, and I want to put the photos in. And this one is actually pretty easy to do with factorial. Because if you think about it, if you've got these 5 pictures to choose from, right? You have 5 choices to pick from for the first option. Any 5 I want. So let's say I chose this one. How many choices do I have left now? Well, I have 4 left, right? And maybe I pick that one, and then 3, and then 2, and then 1, which is the same thing as 5 factorial. And 5 times 4 times 3 times 2 times 1 is 120. I have 120 ways that I can organize my photos. Okay, and that'll be it for this.